be 2. My x is 2 here, then I'll have 2 plus 1 on this side equals to a into 2 minus 1 plus b into 2 minus 2. 2 minus 2 is 0, this one cancelled, then I'll have a into 1, then this one is 3. 1 times a equals to 3. So definitely my a will now be equals to 3. So let me go back to this partial fraction. So here now, this is my linear expression now. I will have x plus 1, x minus 2, x minus 1. That's what I'm going to have. Then I've calculated my a to be what? 3. So anywhere I see a, I will replace it with 3. So I have to come 3 over, what do I have here? X minus 2 plus, what's my b? My b is minus 2, so I have minus 2 over x minus 1. So I will now have x plus 1 by x minus 2, x minus 1. So I have 3 over x minus 2. Minus times plus minus 2 into x minus 1. Why do I need this? Because I can't integrate this directly. It is difficult to integrate this directly, so I must use the concept of partial fraction to break this complex situation into a simpler situation that can integrate easily. And that is my interest. So I have, integral of this dx is also the same as the integral of this dx, because this is giving rise to this. So I can now bring this forth. I have integral of 3x minus 2 minus 2x minus 1 dx. So which can be written as integral of 3 over x minus 2 dx minus integral of 2 over x minus 1 dx. So I can now integrate this directly. But before I integrate this, remember that this 3 can come out. Since it's a constant, you can have it like this: 3 into 1 over x minus 1, minus 2 rather, dx, minus, this is also a constant, can come out of the integral, and you have 1 over x minus 1 dx. Now, recall this anytime you have a situation like this, that if you have an integral of f of x, f prime of x over f of x dx, if you differentiate your denominator and you arrive at your numerator, you write ln of the denominator, then plus c. This is an important identity in integration. If you differentiate this one, you have what? F prime of x. And what do you have here? F prime of x. If you differentiate the denominator and you have the numerator, then you write ln of the denominator plus c. So here, if I differentiate x, I will have 1. If I differentiate minus 2 is a constant, it will be 0. So if I differentiate this, I will have the numerator. So automatically I can write this as 3 ln of the denominator, x minus 2. That's the first case. Minus 2 is here. If I differentiate x minus 1, I will have 1, and this is also 1. So I can write ln of x minus 1 plus c. So this is my answer for the first question. That's what is known as integration by partial fraction. Now, the second part. This is a complex situation compared to the A part, because here you have a polynomial of degree 3, but here you have a polynomial of degree 2. So here, the first thing we have to do is to look for the factor of the denominator. We have x cubed minus x squared plus x minus 1. So here, how do I know the factors of this? And by factor theorem, when I substitute the value of x and I arrive at, and my result is 0, automatically that particular value of x will definitely be a solution to that polynomial, and that x being transferred to the other side will now be a factor of the polynomial. What am I saying? So if I have x cubed minus x squared plus x minus 1 is equal to 0. For this to be, if I want to know the value of x, that will make this, that means by factor theorem, f of r equals to 0. If f of r is equal to 0, or f of minus b over a equals to 0, that's for ax plus b case, then this, the value of that x is a solution to the polynomial. Then that is what factor theorem is telling us. So what am I going to test for that? Let me assume that my x is 1. If I put x equals to 1 here, what do I have? I have 1 cube minus 1 square plus 1 minus 1 equals to 0. Is it going to be equals to 0? Let's see. 1 minus 1 plus 1 minus 1. 1 minus 1, 0. 1 minus 1, 0. Automatically, that means x equals to 1 is a solution to this polynomial. Then x minus 1 will definitely be a factor of this polynomial. Now, let me resolve to what is known as long division method to get other factors. So I have x minus 1 into x cubed minus x squared plus x minus 1. X divided by x cubed, I have x squared. X squared multiplied by x, that will be x cubed. X squared multiplied by this minus x squared. As I introduce minus. X squared, x cubed minus x cubed, 0. Now cancel. Minus x squared minus x squared minus x squared. That will be minus x squared minus x squared. So this one will be minus x squared plus x squared. And this one also cancel. Then I bring this one down. So x in x, that's plus 1. 1 times x, that will be x. 1 times this, minus 1. So automatically, I will have x minus x, 0, 0. So automatically, I will have x minus 1, then x squared plus 1. This I have this and this. So automatically, I've succeeded in breaking this complex situation to a simpler situation. So automatically, I can now rewrite this as integral of x plus 2 into x minus 1, x squared plus 1 dx. So I can now break this by partial fraction, x plus 2 into x minus 1, x squared plus 1. Then I have a, which is the first constant, over a linear. Now, the second one is never a linear, rather than a quadratic. So automatically that means to be a linear expression that will be on it, bx plus c. To be a linear expression that will be on it. To be a linear expression that will be on it. So automatically, what I'm going to have is this. So the LCM still remains the same. So I have x plus 2. LCM is still the same, x minus 1, x squared plus 1. So use this to multiply this, I have this. Use this to multiply this, I have this. Plus use this to multiply this, then I have bx plus c over x minus 1. So here, I want to, what am I to eliminate first? Let me eliminate b and c first. So let x be equals to 1. So I have 1 plus 2 equals to a into 1 squared plus 1 plus b x plus c. Then this one is 1 minus 1, which is 0. 0 times everything here becomes 0. So I have 3 equals to 1 squared. 1 squared is 1. 1 plus 1, 2. 2 times 2a. So automatically, which implies that my a will definitely be 3 over 2. Then the second situation, I want my x to be 0. So when my x is 0, I will definitely have when x is 0, so that I can cancel b, because b is bx. So when x is 0, b vanishes. So my calculator can have 0 plus 2. 2 equals to, this one is a, 0 square plus 1 plus b 0 plus c 0 minus 1. So this one will be 2 equals to a plus c into minus 1. So that will be 2 into, what's a? 3 over 2 minus c. So my c will now be 3 over 2 minus 2. And that will give us what? LCM is 2, 3 minus 4. And that will be minus 1 over 2. That's my c. So I want to calculate my b now. To calculate my b, let me just assume that x is equal to 1. So and I'll put in my values. So when x equals to 1, I'm still using this one as my original equation. 1 plus this, that gives me 3. Then what do you have here? 1 squared, 2.